Welcome to BTEC Revision. In today's lesson, we're looking at angular work done. By the end, we should be able to calculate the work done on objects when rotating. Angular work done is the work done by a torque moving through an angle. The equation for work done is torque times angular displacement. The short form is W equals tau times theta, where W stands for work done, tau stands for torque, and theta stands for angular displacement. The units are joules for work done, because it's a form of energy, and torque is measured in Newton meters, and angular displacement is measured in radians. If you remember from a previous lesson, S equals r theta. When we look at a section of a circle, the theta is the angular displacement, r is the radius, and S is the arc length, or the displacement. And we remember from the previous lesson about work done, that is equal to force times the displacement. So we know when we're looking at work done, when you have a angular movement, you can replace the displacement here with r theta, which gives us f r theta. And if you remember from the previous lesson, force times the perpendicular distance is equal to torque. So therefore, this becomes torque times angular displacement, which is this equation here. Let's look at this example. A force of 10 newtons is applied perpendicularly to a lever of length 0.5 meters. The lever is rotated through an angle of 1 radian. Calculate the work done. We can start by writing down the equation. Work done equals the torque times angular displacement. And the torque here is force times distance. And we're going to multiply by theta, which is 1 radian. So now we can plug in all our values. Force is 10 times the distance, 0.5 times the angle of 1, which gives us a value of 5 joule. Now pause the video here and attempt this exam question. For this, the first thing we should know is that the angle is in degrees. So the first thing we should do is convert that to radian. So if the angle equals 90 degrees, and we know that 360 degrees is 2 pi radians, so we can say 180 is equal to pi, and therefore 90 degrees is equal to pi over 2. So 90 degrees is pi over 2 radians. And we have the force of 20, and we have a radius of 0.5. So the work done is equal to torque times theta, which is angular displacement, and that's equal to force times distance times theta here, and that's 20 times 0.5 times angle of pi over 2, which gives us a value of 5 pi. Now, the question's asking for the value in millijoules. So in order to do that, we could, so that's going to be in joules. So to add in millijoules, we will multiply the top, the numerator, and the bottom denominator by milli. That's milli divided by milli. And we want millijoules, so we'll get rid of the milli at the bottom. Okay, so that would be divided by 10 to the negative 3. And we can simplify that further. It gives us 5 pi times 10 to the power 3 millijoules. and multiply 5, which would give us work done equals 15.71 times 10 to the 3 millijoules. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions at btechrevision.com, where there's lots more resources. See you next lesson.